Okay, in the last video we talked about position time graphs, and hopefully we made some sense out of that. Now we're going to change to velocity time graphs. Rather than measuring the object's position every second, we'll be measuring its speed. And the problem is that you're going to have to be able to mentally go back and forth. Position time graph, you have to look at it a certain way, and if it's a velocity time graph, you have to look at it differently. So, in this one, I got to think about what this is telling me. This is velocity, all right, how fast it's actually moving. So the velocity here is 4, and down here the velocity is 0. So it actually is slowing down. So when the line tilts like that, it means I have a changing speed. Before, a changing speed made the line curve on a position time graph, but for this one, if it's tilted, it's changing speed. Okay, and a flat line would be constant speed. So if we look, say, from C to D, it's staying at -2 the whole time, so the speed is -2 the whole way. If it is below the axis, it means there's a negative velocity. It means it's moving in a negative x direction. So again, when we study the position time graphs, tilting downward meant it was going in a -x direction. In this case, anything below the x-axis is going to be moving in a negative x direction. If it's tilting toward the x-axis, like A to B, if I look at A to B, speed is going from 4 down to 0. So if it's tilting toward the x-axis, it's tilting or moving toward B equals 0, that's going to mean it's slowing down. And if it's tilting away from the axis, say from B to C, from B to C it's going from a velocity of 0 at rest to a velocity of -2. -2 means 2 in the negative direction. So its speed's going from 0 to 2, so it's actually speeding up. Now, the slope. The slope for this type of line, change in y over change in x, becomes change in velocity over change in time. And change velocity over change in time, we already saw, was defined as the acceleration. So the slope is the acceleration. And then the area between the line and the x-axis is the displacement. That's not obvious, okay, but if I want to find the displacement delta x for this, it's the area between the line and the x-axis. So for A to B, it would be this triangle. All right, so we'll do this example using this graph. So we're going to look at A to B, and then we're going to look at B to C, and then we're going to look at C to B. Okay, A to B. When I'm going from A to B, what do I know about it? Let's just try to figure out what it's doing first before we can do math with it. So it's tilting, so I know it's changing speed. Okay? If it's changing speed, I got to figure out speeding up or slowing down. So in this case, the velocity is going from 4 to 0. So I'm going to say it's slowing down. Okay? And that was this rule here that is tilting towards the x-axis. Is it moving in a positive direction or a negative direction? The velocity is always positive for that section. It's above the x-axis, so therefore it's moving in a positive direction. Okay? Now we can calculate the acceleration. The acceleration is change in velocity over change in time. We always do final minus initial for this. So it's going to be v2 minus v1 over t2 minus v1. So it ends at 0 here. It started at 4 there. So it's going to be 0 minus 4 meters per second over. And then my time is from 0 to 6. So 6 minus 0. And that gives me -0.66 meters per second, repeating. Now, what does a negative acceleration mean? And that's a little confusing. It means the direction of the acceleration, or the direction it's being pushed, is negative. So let's see if this makes sense. It's moving in a positive direction, but it's being pushed in a negative direction. So if I think about that, if I'm moving this way, but the acceleration is that way, that's going to make me slow down, because I'm being pushed in the opposite direction I'm moving. And we set that right here. So it does make sense. Now, the last thing is the area displacement. So we could say delta x is the area. Triangle here, or my area, it's a triangle. How do I find the area of a triangle? It's base times height divided by 2. So the base of that triangle is 0 to 6. It's 6 seconds. The height of the triangle is on the y-axis. It's from 0 to 4, so it's 4 meters per second. And then I got to remember to divide that by 2 because it's a triangle. My seconds cancel, and I have 6 times 4 is 24, divided by 2 is 12. So since the seconds cancel, I'm left with meters. So delta x is 12 meters. And it's positive, and we said it's moving in the positive direction, so its displacement has to be positive. So all this stuff ends up kind of matching what we decided it would look like. From B to C. From B to C, figure out first, I'm going to say it is moving in a negative x direction because it's below the axis. All right. It's changing speed because it's tilting. And it's speeding up because it starts with a velocity of 0, ends with a velocity of 2 in the negative direction. So 2, even in the negative direction, is faster than 0. Now, my acceleration is delta v over delta t. So for this one, it ended at negative 2, started at 0, and it did it in, it ended at 9 seconds, started at 6 seconds, so 9 minus 6 seconds. And I'm going to end up with an acceleration of negative 0.66 repeating meters per second squared. Again, it's actually the same thing as I had before. One way to know it's going to be the same, A to C is a straight line, so it has a continuous slope. The slope is the acceleration, so A to B is going to have the same slope as B to C as acceleration. But it's causing it to do something different. Here it was causing it to slow down, here it's causing it to speed up. How can the same acceleration cause two different things? It's all about direction again. Okay? In this one, the velocity is this way, okay, in the negative direction. Acceleration is also in the negative direction. Okay, so the push is in the same direction it's moving, and that's going to cause it to speed up. So that makes sense too. So we tend to think of it as negative acceleration as making things slow down, but that's not true. The direction of the acceleration is the same as the velocity to speed up, but if the acceleration is the opposite direction, it's going to slow down. Last thing is our displacement, delta x. And again, we get a triangle. We go x-axis to the line, so here we go, like that. Right? So it's base times height divided by 2 again. This time the base is 3 seconds because it was 6 to 9. The height is minus 2 meters per second. Negative height may not make a whole lot of sense, but it's 2 below the axis, so that's why I use negative 2 there. And then I divide that by 2 for the triangle, and when I do this, I end up with minus 3 meters, so delta x is negative 3. Now just glancing at it, I can tell that it doesn't go in the negative direction as far as it did in the forward direction, because there's a lot less negative area than there is positive area. Now, C to D, hopefully we're starting to get the hang of this. Is it going in the positive direction or the negative direction? So think about that. It's below the axis, so it has a negative velocity, so negative direction. All right. Second thing, speeding up, slowing down, or constant speed. It starts at 2, ends at 2, it's 2 the whole way, so it's a constant speed. Okay, and we can tell that because it's a flat line. All right, next is the acceleration. Well, if it's constant speed, the acceleration is 0. And that makes sense because the slope of the line from C to D, it's a flat line, the slope is 0. And then the displacement, and remember, it's the area from the x-axis to the line. So this is a different shape. It's a rectangle, so we have to be aware that that can happen too. So that's going to be base times height. Now the base is the amount of time. So base is from 9 to 14, that's 5 seconds. The height is -2 meters per second again, and that gives me delta x of -10 meters. So hopefully that made some sense. Like I said, the tricky part is going to be going back and forth in your head from position time graphs to velocity time graphs.